Welcome to the chapter Heights and Distances in Trigonometry. So before we start, let us understand these terms: angle of depression and angle of elevation. Suppose the OB is a plane and a person is standing at O and he is observing a object at the point P. So now this is the line of sight. From here he is observing the object P. So this angle, that is the angle between the horizontal, that is on the ground, and his line of sight, that is called the angle of elevation. And another term is angle of depression, that is the observer is at the point P, which is at a height of certain distance from the ground, and he is seeing some object on the ground. So from top he is seeing it down. So that is why it is called angle of depression. When you are seeing up, it is angle of elevation, and when from P you are seeing an object on the ground at the point O, so this line is called the angle of depression. So angle of elevation and angle of depression are always along the, here angle of elevation is along the ground, and here a line parallel to the ground. So you cannot suppose there is a building over here, and then from the top of the building you are seeing an object at O. You cannot take the angle between angle of depression as the building and the line of sight. So you have to always take along the line parallel to the ground. When you do the problems, you will be able to do it. Now coming to the problem, we'll start with very simple problems and then we may go to the more tougher problems. The string of a kite is 100 meters long and it makes an angle of 60 degrees with the horizontal. Find the height of the kite. So let us, this is the ground. So this is A, B, and it makes an angle 60 degrees with a string of a kite is 100 meters long. So here this is a kite. And it is making 60 degrees. Find the height of the kite. Now height is always a perpendicular distance. If they had given some other details and asked you to find the length of the kite, then you will have to find this length. Now it is, so let us put this point as B and this is C. Now it is given the string of the kite is 100 meters. So AC is the kite equal to 100 meters and this angle of elevation is 60 degrees. Now we have to find the height of the kite. Now we have to find BC. Now we know sine 60 is equal to opposite side by hypotenuse. So this is 90 degrees. So hypotenuse is AC. So sine 60 is root 3 by 2 and BC by 100. From this BC is equal to 50 root 3 meters. If root 3 is equal to, the value is given, you can multiply and put, otherwise you can leave it as it is. So the answer is 50 root 3 meters. An electrician has to repair an electric fault on a pole of height 4 meter. He needs to reach a point. So we will first draw the figure. So A, C, and this is the ground. So the pole height is 4 meters. So AC is equal to 4. He needs to reach a point 1.3 meters below the top of the pole. So this point, let it be B. So that is AB is equal to 1.3. what should be the height of the ladder, so that he should use height of the ladder that he should use, which when inclined at an angle of 60 degrees to the horizontal would enable to him to reach the required position. So now now this is the ladder. So BD is the ladder. This is what we have to find. Length of the ladder is what we have to find. They have given this is 60 degrees. So that now we know the total length AC is 4. So now this is always perpendicular. So BC is equal to AC minus AB. This is 4 minus 1.3, that is equal to 2.7 meters. So therefore, now we have to find BD. BD is equal to, so sin 60 is equal to BC by BD. Opposite side by hypotenuse. So sin 60 is root 3 by 2 is equal to 2.7 by BD. So BD is equal to 2.7 into 2 by root 3. So 5.4 by root 3. This you can rationalize. Generally we don't put the root in the denominator. So rationalizing. So for rationalizing you will multiply root 3 in the numerator and denominator. So it becomes 5.4 root 3 by 3. So that becomes 1.8 root 3 meters. Now a tree is broken by the wind. So the length of the ladder is 1.8 root 3 meters. A tree is broken by the wind. The top struck the ground at an angle of 30 degrees and at a distance of 30 meters from the root. Find the height of the tree. So this is the ground. Now this is the length of the tree, but the tree has not completely broken. If it had completely broken, then it would have fallen on the ground, but it is broken at a certain point. And the tree is fallen like this now. This is actually the tree. Now it has fallen on the ground in this, and at a distance of 30 meters from the root. So this is the root. So this length is 30. So suppose we are writing this as A, B, C and D. So actually CD is equal to AC, because the tree is breaking at the point C, and this distance is given as 30 and angle is given as 30 degrees. So we have to find BD, the whole height of the tree. BD is what we have to find, the whole height of the tree. So now here adjacent side is given. Now we have to find both this side and this side. So let us first find sin 30 is equal to, cos 30 is equal to. Sin 30 we cannot use, opposite side by hypotenuse we do not know either of the values, so we will use cos 30 is equal to adjacent side by hypotenuse, that is AB by AC. Cos 30 is equal to root 3 by 2 is equal to AB is 30 by AC. From this you will get AC. So AZ is equal to 60 by root 3. So same way you will multiply by root 3 by root 3. So it becomes, denominator will become 3. 3 divided by 60 divided by 3, 20. So this is 20 root 3. So you got AC as 20 root 3. Now we have to find BC. Now we can use sin 30. Sin 30 is equal to BC by AC. Sin 30 is half, is equal to, BC is what we have to find now. BC by AC is 20 root 3. So BC is equal to 20 root 3 divided by 2, that is equal to 10 root 3. So now the height of the tree is equal to AC plus BC. Height of the tree is actually CD plus BC, but CD is equal to AC, so AC plus BC. So AC is 20 root 3 and BC is 10 root 3. So 20 root 3 plus 10 root 3 is equal to 30 root 3 meters.